let's go ahead and take a look at using the law of sines to solve a side-side angled triangle. This time we're going to be looking at the case where we have two solutions, or two different triangles, and we're given some information about our triangle. Side A has a length of 6, side B has a length of 8, and we have angle A is 35 degrees. And so we'll need to solve for the rest of our information on this one. So let's go ahead and use law of sines to find angle B. So we've got sine of A, which is 35 degrees, over side A, which is 6, and sine B over side B, which is 8. And let's go ahead and cross multiply. So we've got 8 times sine of 35. And we're going to go ahead and divide that by 6. Right, and keep in mind we're solving for B, so we're going to have to go ahead and take inverse sine of both sides. And we can go ahead and type this into our calculator. Again, you're going to want to work in degree mode on this one. And let's go ahead and take our degree measure out to 1 decimal place. And this is going to give us 49.9 degrees. And so let's go ahead and call this our B1 value. Now remember that when you're looking for a potential second triangle, you're going to be taking this angle measure that you just found, and you're going to be subtracting it from 180. So I'm going to write 180 minus my B1 value here. So I'm going to go ahead and subtract my 49.9 degrees. And this is going to give me 130.1 degrees. And this is going to be my potential B2 in a second triangle. So let me go ahead and jot down some of my information up here. My B1 value that we originally found was this 49.9 degrees, right? So we know we have at least one triangle here. Let me go ahead and change colors, and let me summarize the information for our second triangle. I'll jot this one down as close as I can get it. Now, some of this information is obviously going to stay the same. Right? My information that I was given, my A value of 6 and my B value of 8, will stay the same. My A value here for my angle A was 35 degrees. Right? And now I can start looking at my alternate information here. My B2 potential value there was 130.1 degrees. And what you want to take a look at with this second triangle are these angle measures that you have. Do you have enough room to fit a third angle in there? If you take a look at A and B2 and add those two numbers together, you're going to realize that's less than 180 degrees, so I can fit a third angle in there. Right? The same type of thing is going to happen with A and B1, right? I can add those two numbers together, they're less than 180 degrees, so I can fit a third angle measure in there. So let's go ahead and calculate our angle measures for our triangles. So let's find C2 first. So I've got A plus B1, sorry, that's a B2, plus C2 is supposed to equal 180 degrees. Alright, so 35 plus 130.1 plus my C2 value here is going to equal 180. So this will be 165.1. And let's go ahead and subtract that from 180. This is going to give us 14.9 degrees. So let's go ahead and calculate our last angle, angle C, from our first triangle. So we have angle A plus angle B1 plus C1 is going to add to be 180 degrees. Okay, so we've got 35 plus the 49.9, and we can go ahead and add those numbers together, and then we can go ahead and subtract those from 180. This will give us 84.9 plus C1 equals 180. So our C1 value should be 95.1 degrees. Okay, and the only piece we have left is to find side C in each of our triangles. So let's go ahead and work with this first triangle. And let's use law of sines. So we've got sine of 35 over 6 equals sine of 95.1 over our C value. So C in this case, once we cross multiply here, we've got 6 times sine of 95.1 divided by sine of 35. And let's go ahead out to 2 decimal places. And this is going to give us a side length of 10.42. And then for our final piece, we'll go back to our second triangle, and let's go ahead and calculate side C for that one. So we've got sine of 35 over 6 equals sine of 14.9 over side C. So again, we're going to cross multiply here. We've got 6 times sine of 14.9 over sine of 35. And we'll do the same thing. Let's take this out to 2 decimal places. And this is going to give us a side length of 2.69. So now we have all the pieces to both of our triangles.